Welcome to this video on load calculation for multifamily units using the optional method. We're going to figure out the minimum overcurrent protection device for these units. I'm going to first go over a summary and also the directions. It'll be a page layout, so you'll see how to fill out your page. It'll summarize all of the rules. And then after that, I'm going to get into a question and then we're going to answer. If you want to find any of my other load calculation videos, just look at the load calculation playlist. That will be linked in the description of this video. Okay, before I get into the summary, let's just go in the code book and let's locate where this information is in the code book. Okay, so we're going to go to article 220.80. We see this is part 4 of the optional feeder and service load calculations. Here we see article 220.82 where it says dwelling unit. Okay, so pay attention to that. It is not plural, it says dwelling unit. So it's pretty vague, but this is telling you this is only for single family dwellings. In other words, the entire article 220.82, we see section A, B, and C. We were using these when we were doing the optional method for single family dwellings. But here when we're doing multifamily, we're not going to be using article 220.82, and furthermore, this is only for dwelling unit, so we're not going to be using it for duplex either. If you pay attention to how I'm ordering my videos, you're going to see that the optional method for multifamily is going to come before my video for the optional method for duplex. And I actually did this on purpose because solving duplex for the optional method is pretty simple, but it's a little bit confusing if you haven't done the multifamily yet. So we're going to first do the multifamily for optional method, and then I'll have the duplex for optional method as my next video, and that's going to be a lot easier first doing this. Okay, we're going to go on to the next page. Again, we see article 220.84 dwelling unit. Here's where it tells us if we have 3 or more dwelling units, it is permissible to use table 220.84, and this is if all of the following conditions are met, where you see underneath it says 1, 2, and 3. And just like a lot of these rules in the load calculations, rule number 1 is the most important. No dwelling unit is supplied by more than one feeder. Okay, so a lot of times they're going to say we have dwelling units all supplied by one feeder. We have duplex units supplied by one feeder. So it's good if they tell you this, but a lot of times they're not going to tell you 2 or 3. And they're not going to directly tell you that. And then we see 2 and 3 are less common, but they're also good to know. So let's just look at them. Each of the dwelling units needs to have electric cooking equipment. In other words, what we call a range. And then we see number 3, that each dwelling has to have its own air conditioning or electric space heating or both. Then number 3, we see each dwelling has to have either air conditioning or heating or both. Okay, and when we're solving these questions, these practice questions and the test and stuff, you can almost guarantee that this information is sort of irrelevant, but it's still good to know. Okay, and most of the time on these practice tests and on the test, you're going to have dwelling units that are supplied by the same feeder. You're also going to have a range, and you're either going to have the heating or the AC. It's just always good to know what the codebook is telling us. Okay, we see table 220.84. We're going to be using this table to figure out our demand factor based on how many units we're working with. We see this is for 3 or more multifamily dwellings, and we see on the left side the number of units in a column going vertically, and on the right we see a similar thing except it's demand factor and it's a percentage. Okay, so we look at the number of units we have on the left. For example, 3 to 5 units gives us on the right side a 45% demand factor. Let's go down to something random. 16 to 17 dwelling units is going to give us a 39% demand factor. Okay, we're going to go over this in the summary and in the example, but basically what we're going to do is we're going to add everything up at full load. We don't have any demand factors until the very end. We have this final demand factor, which applies to everything. And this is different because for the single family dwellings, we added everything together besides the heat or the AC, whichever one was bigger, and then we added that back at the end, and we're not actually doing that this time. Also, the single family dwellings had their own specific demand factors, which I have a whole video about that, so I don't need to mix that up into here, but we don't have those same demand factors here. We're using this table for the optional method for multifamily, and if you need a refresher on single family optional method, just check out my video again. And if you're also thinking right now, well, what do you do for duplex then? Well, then check out my duplex video. That will be out right after this. Okay, so now we know what the codebook is telling us. We know why we're doing what we're doing, and we know where to find the one table that we're using to find the demand factors at the very end. Okay, so now I'm going to get into the summary and the page layout. Okay, every time, no matter if we're doing optional method or standard method, we're always going to have our square feet, and we're also going to always times that by 3 volt amps. No matter if we're optional or standard method, we need 3 volt amps per square foot. When we multiply those together, we're going to get a number I'm going to call N, and then at almost all times, we're going to add 4,500 to that. The reason why it's almost all times is because you might have an exception once in a while that's telling you to not include your laundry load. If you want a more in-depth explanation of that, just check out my residential load calculation video part 3. But it's basically good to know that in the code book, you do have an exception that allows you to not include the laundry load. So if they mention to not include the laundry load, then you're still going to include your two 1500 volt amp circuits that are for your small appliance branch circuit, so a total of 3000 volt amps. But you're not going to have the additional 1500 for the laundry circuit. Then when we add those two numbers together, of course, we're going to get another number. And normally we have demand factors from here using the standard method. This is where the optional method is different because we don't have demand factors at this point. So I'm not going to write no demand factor like I have here for every one. But on this one, for the general lighting load, by now we're probably used to doing the demand factors in the standard method. And we need to sort of remind ourselves that we are not doing those demand factors. We're just going to do square foot times 3 volt amps. We're going to get that number plus 4,500. That total number is not going to have any demand factors. But what it is going to have is the amount of units. So you need to remember that how many units you have, you need to multiply that. So that's why I'm just putting times units here. Let's say if we're working with 15 units. This would say times 15 in parentheses. I use this in parentheses because, for example, you might have 2 of a certain appliance in a house. Let's say you have 2 water heaters. Then you need to remember to multiply that by 2 for each unit. And then you also need to multiply by the amount of units you have. So that's why if you only put the parentheses for when it's the amount of units, you can quickly look at that portion and you can easily see that you correctly multiplied by the amount of units. And then you can also see that you multiplied by the amount of appliances, since that won't be in parentheses. And we're going to see I create sections out of this, so I don't do it all in one. Okay, so that's this first section, the general lighting load section. After we have everything, of course, no demand factors, and we make sure to multiply by the amount of units that we have, we're going to get a total number. Okay, and I'm going to label that total number with GLL as the general lighting load. Okay, normally there'd be, of course, a number in this circle as well, telling me the total demanded load, as it's called, for this section. Okay, and I like to divide each section with a solid line that's very visible. Okay, there's my first section, and if my head gets in the way at any point during this, I'm going to move out of the way after I write everything, after it's all filled out, and you're going to have time to look at everything, screenshot it, or whatever you want to do. Okay, so now for the next section, I do appliances. I do this the same order. If it's standard method or optional method, I do everything the same order, and this limits a lot of confusion. Okay, so appliances, I a lot of times just call APP for short. It's a lot to write out the whole word. It doesn't matter how many appliances you have, what the rating for those appliances are. For example, if they are 500 watts or greater, or if they are less than 500 watts, it doesn't matter for this portion. Everything is at 100%. What we really need to keep in mind, of course, is that for every single section, we need to multiply by the amount of units that we have. And because I put it in parentheses every time, I'm not going to miss it. I'm going to look at the last section that I just did, and I'm going to see the amount of units in parentheses. And it sticks out a lot. Okay, so now I'm done with this section. That's all you have to do. All of your appliances at 100%, but you need to make sure to multiply by the amount of units that you have, and you want to label that somewhere in there on your paper so you can actually see that if you look back at it. Okay, and again, I'm separating each section with a line that is very easy to see. Okay, now I'm about to move on to the next section, but I just want to mention, just like before, when I get my total number for my appliances, of course, then I'm going to label that in a circle with that total number, and I'm going to label it APP. So when I quickly look back at this section, of course, not only am I double checking that I did the math correctly, but I can see that total answer with the label inside of it. Of course, it's in its own section, but when you start filling out a paper with a bunch of little things, it's good to label things multiple times so you can not only see that you're working in the section of appliances, but when things get all messy and kind of crazy looking, you can see your total number and you can see it's labeled with the appliances. Okay, next we have HARD, and I normally do draw it just like this to where the H and the A are a lot closer, and then the R and the D have a space. And this is because, like always, for the heat and the AC, we're picking the bigger one. Okay, it's good to know that using the optional method, you do have demand factors for your heating if you're doing a single family dwelling. But here we're doing multifamily. This is not in the article. And just if you want to see this, if you go to article 220.82, you're going to see that section C is where you're going to find those demand factors for heating. And you don't have demand factors for air conditioning, but you do for heating, but that's only for single family dwellings. Or if there's a question out of context, for example, if they don't tell you that you're working with a duplex or a multifamily, but if they say we have 6 space heaters using the optional method, what is the total demanded load? Then we're going to see that under Article 220.82, Section C, and then subsection 5, we're going to see that if we have 4 or more separately controlled heating units, we're going to be using a 40% demand factor. Okay, so it's good to know that, and it's also good to know that you don't do that for multifamily and duplex, so we're going to be doing everything here at 100%. It's pretty simple here for the optional method. In multifamily, it's pretty straightforward because we're used to doing demand factors for each section, and for the appliances, we have specific rules. But in fact, for the optional method, we're just doing everything at 100%. Of course, for the heat and the AC, we're going to pick the bigger of the two. So let's see, the AC is the bigger one. Then we're just going to get rid of the heat, and we're going to disregard that number. And we're just going to use the number for the air conditioning. Just like always, after we pick the bigger one, I'm going to get that total number. Okay, after we pick the bigger one, if we didn't already do this, we need to make sure that we're multiplying by the amount of units that we have, because that's going to give us the actual total demanded load for this multifamily dwelling. Once we get our total number, we're going to circle it so it's very visible, and then we're going to label it. For this example, I said we're going to choose the AC because that's bigger, and we're going to label it AC with the total number inside of that. Now we're going to move on to range. Again, you can draw lines for each one of these sections, of course, if you want, and separate them, but I normally don't. And I've also found that with my method of circling the answer and then labeling it, then I seem to not have any trouble finding out my answer at the end or have any confusion. Okay, so the next section is the range. This is, of course, at 100%. And of course, all that we need to do from here is multiply by the amount of units that we have. We're going to get that total number, and we're going to circle it, and then we're going to label it. Of course, you can just put an R. I'll just actually put range most of the time. And then same thing for dryer. Dryers are at 100%. We don't have any demand factors like we're normally used to for standard method. We're going to multiply by the amount of units that we have, and we're going to get that total number, and we're going to give it a nice circle that's very visible. And we're going to label that number with what it is associated with, which is the dryer. Okay, and now we do not have the 25% of the largest motor. We only do that when we're dealing with the standard method. When we're dealing with the optional method, we do not ever do the 25% of the largest motor. The optional method is sort of a simpler, faster method. So you're leaving out a lot of demand factors throughout the way, a lot of specific rules, and you're just doing one big demand factor at the very end. Okay, so now that's the next step, but first we can add everything together. We have the total number for general lighting, appliance, air conditioning, because we picked the air conditioning out of heater or AC, we picked the bigger one. We also have the range and the dryer. Okay, I'm just like imagining we have all these numbers. Okay, so we see all the circles. At this point, we can add everything together, and then we're gonna get a total number. I'm just gonna call it T. Of course, when you get your total number, write it down, and then add everything together a second time to make sure that you get the correct answer. It's also good to double check other things along the way as you're doing it, which I'm actually going to show you in my example. I'm not going to show me double checking anything, but I'll explain when is a good time to. Okay, so we have that total number and we double checked it and we see everything adds up correctly. Now we're going to open up our code book and we're going to go to table 220.84. We're going to look at the total number of units that we have. Let's say we have 15. We're going to look and we see 14 through 15 and we see that is a 40% demand factor. We're going to multiply our total number by our demand factor and we're going to get our final answer. And to be more specific, these are going to be our final watts or volt amps. Here in the load calculations, we're not going to differentiate watts and volt amps because we're not going to be thinking about power factors or anything like that. I do a lot of circles throughout this, but I like to box my final answer. It's a very common thing in math. So here's my final answer boxed, and this is the final wattage. From here, we want to find out the minimum overcurrent protection device. So we're going to divide that final wattage by 240 volts. Okay, because that is wattage, or in other words, volt amps. We're going to divide it by 240 volts. I'm running out of a little bit of room here, but that's going to equal our amps. Okay, and a lot of times we're not going to be done after we find our amps. The reason is because this number is oftentimes not going to be a standard rating for a circuit breaker. From finding our amps, we're going to go to table 240.6a, and in here we're going to see our actual standard ampere ratings. Now this is just the summary, so I'm just going to summarize this, but I'll actually explain this more in depth when I get to this at the end of the actual question, and that is that article 240.4 section B is going to tell us that if our next standard sized circuit breaker is 800 amps or less, then we're going to size up. But if it is over that, then we're not going to size up. And in that case, if we're in the middle of two numbers and we're over 800 amps, we're actually going to size down. So let's look at table 240.6a. If we ended up with 760 amps after dividing by 240 volts, we'd go to table 240.6a, of course, and we see 700 and 800. Okay, so that's in the middle of both of those. And in that case, we're actually going to round up to 800 because we can round up to 800 or less. And that's the limit. Okay, but if our number was, for example, 960, once we divide it by 240, we look at the table, we see that's in the middle of 800 and 1,000, okay? But that's over 800, so in that case, we're not going to size up to 1,000. We're actually going to size back down to 800. Okay, and that's how you find that minimum overcurrent protection device. So that's how you solve everything. Okay, now if you want to see what size wire you're using, you're going to be using table 310.12. If your service is between 100 and 400 amps. And if you have further questions about this, read article 310.12. Okay, so that is it for the summary as well as the page layout. This shows you how you can lay out your page if you're going to solve this. And this is without the numbers. So when I actually get to the example in the next portion, I'm actually going to show you how I lay out my page with the numbers. Of course, it's going to help you a lot to actually do this with me and not only watch me do it. But where this is really going to help you is when you take the question that I give you and solve for it on your own without me doing it along with you. If this is your first time doing this, this might seem kind of crazy. But after doing this multiple times, this is actually really easy. And doing the page layout helps a lot because you can just lay out your page a certain way and then you just fill in the blanks. And if you get confused along the way at any point and you forget how to do something, then you just look in your code book and you should have things highlighted, underlined, and whatnot. And you should be able to find whatever you need. Okay, of course, now's your moment if you want to screenshot this or pause this and write this down or anything. Okay, before moving on, I just want to mention that we can see every single section clearly separated, and then we can also see that we have the amount of units in each section. General lighting, appliance, the bigger of the heater AC, the range, and the dryer. When we actually have all of the numbers filled out, this is going to help a lot, because we're easily going to see the parentheses times the amount of unit. And then next, we're going to see our total number for each section circled with the total number inside of it. It's good to then leave enough room at the bottom of your page to be able to have your total number, do the demand factors, and also divide by 240, all that stuff. Find your minimum overcurrent protection device. And the reason you probably want it at the bottom is just so you can easily see everything and you're not going to somewhere random on your page going to have to do the very last step. That can be kind of confusing. You have all these numbers everywhere. Okay, so try to plan ahead and try to not write too big. I'm writing pretty big here because I want you to be able to read this. but try to write pretty small, have a sharp pencil if you can, but then also clearly label things and do things a certain way in order so then you don't confuse yourself, and it'll be pretty straightforward. Okay, now I'm going to read off the question, but it's good to know that on the test, they're not going to make it super straightforward for you. So a lot of times on these practice questions, they're going to say something like, using the optional method, figure out this load calculation. But on the test, they're a lot of times going to give you all the information about the load calculation and then tell you something like it's the optional method at the very end, like the very last thing they tell you. So that's why it's good to sometimes glance over a question before you read it, for one, but also to read the entire question at least one time before you write anything down. So when I read off this question, you'll see it written down in front of you. I'm not going to mention that it's the optional method in the beginning, and I'm going to mention it at the very end. And I'm telling you this now because this might seem kind of weird, but this is actually going to help train you for if someone, for example, told you at the very end of a load calculation that, oh, by the way, I wanted the optional method. Find the total demanded load for the following situation. A 15 unit which has the following in each dwellings: 1,600 square feet, an 18 kilowatt heating system, a 10 kilowatt air conditioning system, a 15 kilowatt range, a dryer, a 4.5 kilowatt hot water tank, a 1.2 kilowatt dishwasher, and a 1 kilowatt disposal. Find the minimum overcurrent protection device using the optional method. Okay, so it might be a little bit ridiculous how I worded the question, and I'm not saying this is exactly how they're going to word it on a test or something like that, but they're going to do something similar, where in the beginning it looks like I'm telling you just to find the total demanded load, and I don't tell you anything, so you think, oh, it's the standard method. And by the time you get to the end, I'm asking for the minimum overcurrent protection device and for it to use the optional method. And it's kind of ridiculous how I worded that, but that is the nature of these test questions. They're often kind of ridiculous, and they're often a lot more vague. So they often give you very little information, and you kind of have to speculate exactly what you have to do. Okay, so now I'm going to write everything down, and I'm going to lay it out just like I showed you in that summary/page layout. We know we have 1,600 square feet in each dwelling, so we're just going to take that 1,600 square feet per each dwelling, multiply it by the 3 volt amps. We're going to get 4,800, and then we're going to add that 4,500 for the 2 small appliance branch circuits and the 1 laundry circuit. We're going to add that together, and to save some room, I'm going to put that right here. You get 9,300. Of course, this is volt amps. Make sure you label everything. You can say volt amps or watts. Again, it doesn't matter. Now remember, we had a 15 unit, so we're going to have to multiply this by 15. I normally like to put a placeholder for times 15 and make it very clear, so when I look over everything, I can make sure that I did this. But with how I just did this, I filled out the beginning of this portion, and now I got to the times 15. For now, I'm just going to do that multiplication, 9,300 times 15, and I'm going to get 139,500. Okay, now remember, we don't have any demand factors. So that's why I just started filling this in. It just finished itself really quickly. So that is the general lighting load portion. And put a little W, make sure to always label it. And there we go, we have the total answer circled with the label GLL for the section. I'm going to get into the next section, so I'm going to draw my line. A lot of times I write down all the information on my paper right away, so I can write down all the information and then double check it before I actually start filling stuff in. And since I normally do that, I'm going to stay true to that. Even though I got a little carried away and I filled in this first portion, I'm still going to do it how I normally do it. Okay, so I'm going to get onto the appliance section next. And I had a hot water tank, dishwasher, and disposal. Pay attention how I abbreviated it. Makes it a lot easier to write it. And their ratings each in kilowatts are 4.5, 1.2, and 1. For now, I'm just going to write the note that we need to multiply by the amount of units we have, which is 15 units. And I'm going to draw my line for the next section. You'd probably draw your line a little more like this, sloppy. I'm actually going to redo this because it's the video. But, you know, your paper is probably going to look a little more sloppy compared to this looking all neat. Of course, you don't have to make it look neat. You just got to leave enough room and plan things carefully. Being neat kind of takes some extra time, but it's good for the video, of course. Okay. In my next section, I have my HARD. I would draw this a little differently, normally on a sheet of paper, but because I'm doing it on the whiteboard here, I'm going to do whatever I can to save enough room and to also keep in mind that I'm going to do some math here with the HARD. And then I'm also going to have to add everything, do the demand factors, and then solve for my minimum overcurrent protection device. So I need to leave enough room for that and keep that in mind right now. I have my H and my A right here. I know using the optional method, I don't need to do an incredible amount of math because it's going to be rated at 100%. So I'm going to draw a line about here, and then I'll have my range and my dryer here. And then I should be able to figure out still enough room to be able to write down the rest of the information in the math that I need. The heating system was at 18 kilowatts and the AC was at 10 kilowatts. We're picking the bigger one here, so of course we can already see that 18 is going to be bigger than 10. So we're going to disregard the AC and we're going to use the heat. And of course, we're going to multiply it by the amount of units that we have. I'm going to write that label now so that I can make sure that that's already there in each section for when I'm going to solve for that and add everything up at the end. We get into the range. We were told that we had a 15 kilowatt range. We don't have demand factors, so again, I'm just going to write that note of multiply by the amount of units we have, multiply by 15. We move on to dryer. We didn't have a nameplate, and we know that dryers need a minimum of 5,000 watts or nameplate rating, whichever one is greater. So we have 5,000 watts there, but to make it easier, we could just call it 5 kilowatts. We need to multiply that by the amount of units we have, so multiply by 15. And now we have all the information that the question gave us written down on the piece of paper. Now we can solve everything, and it's going to be pretty simple here with the optional method. We already solved the general lighting load portion, so I'm just going to get into the appliance section. We're going to add the appliances together. 4.5 plus 1.2 plus 1. We get 6.7. And I kind of already wrote times 15 here. I probably should have kept that in mind and wrote a little bit of some space. But we have 15 times 6.7. And we get 100.5 kilowatts. So we could always change that to 100,500. And of course, label it watts. I put a W there. And don't only label the fact that it's watts, but also the fact that this is the number for our appliance load. So now we have the appliance and the general lighting, and I can quickly glance and I can see that, okay, yes, I multiplied by the amount of units I have. If I forgot to do that, my number's going to be drastically different. Then I get on to heat, and I have 18 kilowatts because I chose that as my bigger one. I'm just going to multiply 18 times 15, and I get 270 kilowatts, and just to write it down, convert it into watts, I have 270,000 watts. A lot of times you're not going to have numbers that are so perfect like this, so it's good to write out the entire number. And we want to label that, of course. That is the heat, so I'll just write heat there. We get on to range. We have 15 kilowatts times 15. If you had one of those teachers that made you do all the multiplication table things, this is where that'll come in handy. And here we have 225 kilowatts, so I'm going to convert it into 225,000 watts. And that is for the range. And of course, I'm going to give it that circle. And then we get onto the dryer, which didn't have a nameplate. So we chose the 5 kilowatt minimum times 15. We have 75 kilowatts. Now we have 75,000 watts, and that is for our dryer. Don't forget to label it. It'll make it a lot easier, and it'll probably actually save you time. Now we have all of our numbers. We can add them together and find our demand factor. Or if you, for some reason, want to find your demand factor first, you can do it that way. Now, I'm just going to add everything together right now, get my total number, and then we're going to look in the code book for the demand factor, and then we'll get our total demanded load for this multifamily. Okay, so we're going to get 139,500 plus 100,500 plus 270,000 plus 225,000 plus 75,000. That ended up giving me 810,000. So now I'm going to add everything back a second time. I'm going to see I get the same exact answer. So now I know that this is my correct answer. Okay, remember, we're not done. We need to do the demand factors. Now we get into the book and we look at table 220.84. We know we're dealing with 15 units, and we see that 14 through 15 units is rated at 40%. Because of this, we're going to multiply that number that we got by 0.4, in other words, 40%. That is going to give us 324,000. Of course, we're dealing with watts still right here, and since that is actually the total answer for our watts, I'm going to put a box around it. But we wanted to find the minimum overcurrent protection device, so we need to divide by 240 volts. And that gives us 1,350, and that is amps. because we had watts, we divided by volts, we have amps. Now remember, we don't know if this is an actual answer here for our breaker size, because this might not be an actual standard size. Find that out, we're going to table 240.6a, and we're going to look for that number 1350. We see 1200 and 1600. So that's in the middle of both of those. Now we're used to sizing up to the next size, but in this case we don't want to because it is over 800 amps. Okay, so if we go a page back to article 240.4, section B, it tells us that we can size up to the next breaker as long as it's 800 amps or less. Okay, so in this case we had 1350, and we're actually going to round down to the 1200, and that's going to be the size of our overcurrent protection device, or what they would also call our service. So we have a 1200 amp service. Of course, I should label it like I label everything, so that is the OCPD. Okay, and that's all. It's really that simple. I took some extra time going kind of slow, explaining some things a few different times. If I got in the way at all throughout the video and you couldn't see something, now's your time to be able to see everything. Screenshot it or write it down if you need to. If you got some extra time, now would be a good time to double check things like seeing that you properly had your square footage, you multiplied it by 3 volt amps, okay, that's the correct number. You added your 4500, that looks like the correct number there. We multiply that by 15. Okay, that makes about sense there. And we see them multiply by 15. We also see these added together to create this number times 15. And then we see that number times 15 equals our other number. And we can just glance at these things and see that everything looks good. If for some reason we saw 18 times 15 and we saw 27,000 or something like that instead of 270,000 here, then we'd probably glance at that and know something doesn't really look right there. But in fact, everything looks right. We see 15 times 15, 5 times 15, and we see the 15 in every separate section that we need. So now we know that we multiplied every section by the proper amount of units, so that when you're doing each section, you should probably double check things. So when you do this first section one time, just do it again a second time quickly, and make sure you get the same answer, and then do that for every section. So the first time, probably do it a little slower. Make sure you're paying a lot of attention. Okay, and our final answer is 324,000 watts and a 1200 amp overcurrent protection device because of that. And again, because the optional method, we only had that one demand factor at the very end. Everything else was at 100%, and we added everything together at 100%. And then we just did the final demand factor at the very end based on how many units that we had. So that's it for this video. Be sure to check out my next video, which is going to go over the optional method for duplex. And it's going to make a lot more sense doing this one first and actually comprehending this and understanding this, and then moving on to the optional method for duplex. If you start with the duplex, it's going to be a lot more confusing. And it's almost like working backwards, even though it might not seem like it. You'll see what I mean when you get on to the next video. As always, if you enjoyed this video, give it a thumbs up to show me you enjoyed it. Share it with a friend that you think will enjoy it. And to keep seeing the videos that I upload, make sure you subscribe. And until next time, take care and goodbye.